All right, awesome. So off we go. We are going to look at some exponent rules here, and we're going to start with the basics. We are going to start with the product rule, okay? The product rule is named the product rule because we have multiplication between two terms with exponents. So looking at this rule, I know before when we were just adding and subtracting polynomials, we said you never add or multiply or change the exponents. That's totally different than what we're looking at today, because today we see things like multiplying terms instead of adding them, or we see these parentheses, we're dividing terms. So be on the lookout if we're doing stuff other than adding terms. You are allowed to change those exponents, and you're supposed to change those exponents. So looking at our product rule, we have these A's and these B's, which might look a little bit funky. Those A's and B's, those just represent any number. So it could be a 2, 3, 9, -4, whatever. Those places will be filled in with numbers. The X's are what we call bases, and those will stay variables. Okay, now our product rule says that if we are taking two terms with the same base and they have exponents, what we do with those exponents is that we add them. Okay, which is a little bit counterintuitive because we see that multiplication sign in the middle and our brains go, ooh, multiply. But with our exponents, we actually want to add. The base will stay the same though. Now, if at any point you're a little bit confused, feel free to throw that raise hand button up so I know that you're confused and I can help you out a little bit more. Now, let's look at example 1 over here then. So example 1, we have h to the second times h to the sixth. You always want to first ask yourself, do they have the same base? So I'm going to ask you guys, do these have the same base? Yes, thank you. They're both an h. They both have the variable h as a base, so we can combine these. So what we're going to do is we're going to use our product rule. We keep the h, and then like our rule says, we just add those exponents. So a plus b, that gives me 2 plus 6, which is 8. And boom, we did it. Yay. Now, if you're wondering, Miss, this doesn't make any sense. Why are you adding the exponents? Let's kind of go back and think about how we got this answer. So using the little raise hand button, how many of you have heard that term expand before in math? If you've heard of expanding? If you've heard of expanding, use the little raise hand button so I know. Maybe? Wow. Okay. So expanding is like the opposite of simplifying. Simplifying, we talked about, is kind of like condensing it, making it its smallest form, combining all of our like terms. Expanding is the opposite. We're making this expression as big as we possibly can, and we're writing out as many things as we possibly can. So if I wanted to expand this h to the second times h to the sixth, remember, this exponent just represents how many times you're multiplying a variable by itself. So I could write h times h for h to the second. And then my expression says we're going to keep multiplying. And then I have h to the sixth. So then that would be h times h times h times h times h times h. And you can see once I've expanded this, that if we were to count these, I have 1, 2, 3, 4, 5, 6, 7, 8 h's, which is how we got our answer. So if you're ever scrambling on an assessment, let's say you lost your notes and you just don't remember what the product rule says to do, you can always expand out the expression and kind of reason through these rules. All right, on a scale of 1 to 5, how good do we feel about the product rule? 1 being, I have no idea what just happened. 5 being, that was pretty easy. And if you have a question, now is also a really good time. Thank you to my people responding. I do appreciate that. So I'm not seeing any 1s or 2s. That makes me feel pretty good. Do you guys want to do that second example, or do we want to move on to the next rule? I'll let you decide. Is there anybody that would like to see the second example? Yeah, okay, good. Okay, so we do have somebody that would like to see it. Let's go through it. So now we have some extra variables and some coefficients out in front. Now coefficients, they follow their own rules. Those are just regular numbers, so those don't follow exponent rules. So if it tells you to multiply and you're looking at those two coefficients, you're literally going to multiply those two numbers. So negative 2 times 7, that would give me negative 14. And then we just look at each variable individually. So we'll first look at the a's. We have an a to the power of 2 and an a to the power of 3. Using my product rule, what should my new exponent be for my variable a? Yeah, 5. Good. And then the b's, now this one's a little bit tricky because we don't see any exponents there, but we should know that there are exponents. What are the exponents of each? Oh, yep, I see you guys already putting it together. That's awesome. We have little invisible 1s here. So if we were to add those up, then we'd have b to the power of 2. And voila, we have our answer. And the reason we were able to do that is because both of these had A's and B's. All right. Any questions on that? Excellent. Okay, so let's move on to the power rule. The power rule, this one looks kind of weird. We see a base, just one base this time, 1x, and then there's kind of like two exponents. There's one exponent inside and one exponent outside. And between them, we see these parentheses. Finn, what do parentheses usually indicate that we have to do in a math problem? If we see parentheses, what operation do we usually have to do, Finn? Oh, yeah, you're thinking about PEMDAS. Yeah, you do have to do what's inside the parentheses. Yes, but when we're talking about like solving and stuff like that, or multiply, there you go. You got my second train of thought. Yeah, so that rule is going to say the same. If you see parentheses, we're going to automatically think multiplication. So with our power rule, if we see one base, two exponents with parentheses in between them, we are going to multiply those two exponents. And the product rule and the power rule, those are probably the most common rules that we're going to see. They are also the most commonly mixed up. So make sure that you can tell the difference between these two rules here. Okay, so let's look at the first one. I have my base x, and then does anybody know what our new exponent will be using our power rule? Killing it. Thank you. 6. Yes, because we did 2 times 3. All right, now I'm going to skip this second example. We'll come back to it at the end. If I forget, will you guys remind me? Thanks. All right, let's look at quotient rule. So let's kind of step back a moment. Quotient means divide. We can tell that. We're looking at, we have our line there, which indicates division. And kind of the opposite of division is multiplication. So if I go back to this product rule, when we were multiplying, we had to add the exponents. So Connor, if when we multiplied, we added the exponents, what do you think we're going to do with our exponents when we're dividing? Yeah, we're going to subtract. Thank you, Connor. So our quotient rule says that if we're dividing, we are going to take our top exponent and subtract our bottom exponent. That one is probably one of the most commonly missed rules because people see division and they just want to divide the numbers. But again, we can figure this out if you go back to that product rule, kind of reason through it a little bit. Just double check that your rules make sense. All right, let's look at our first example. So right now we see all these numbers in front. I kind of want to ignore those coefficients for a moment and just look at our variables, our x's. Okay, so kind of ignore the 27 and the 42 for a moment. If we just had x to the 5th over x. Now, first of all, I hope we all know there is no exponent in this bottom part. What is our invisible exponent here? Yes, thank you. Seeing lots of right answers in the chat. We have an invisible 1. Okay, so now just looking at this part, Soraya, what would my new exponent be if I were to use my quotient rule here? So using this rule, what would my new exponent be? So let's look. We have, we're using our quotient rule. We have a 5 on top and a 1 on bottom. And our rule says if we're dividing, we're supposed to subtract those exponents. So if we subtract those exponents, what would my new exponent be? Yeah, 4. We always try to make it harder on ourselves, I think. So 5 minus 1 gave us 4. So we have x to the 4th power. Good job. And then we did kind of step away from our coefficients for a moment. So now I need to go back to those and kind of reevaluate those for a moment. So 42 does not go into 27. If you type that in, you're going to get a nasty, ugly decimal. So instead, our goal, we are going to try and simplify this fraction as much as possible. So we need to think of numbers that go into both 27 and 42. Anybody have any ideas? Numbers that go into both 27 and 42. Thank you, Evelyn. Yeah, 3. So if we take the top and divide it by 3, we're going to get 9. If we take the 42 and divide it by 3, we're going to get 14. So our most simplified version of this would be 9/14 x to the 4th. What questions do we have? All right, let's try that second one. I'm going to give you guys about 40 seconds here to try this second problem on your own, and then I'll call on some helpers to help me figure it out. So try this second example. You are going to have to do kind of 2 steps here, so be careful, maybe even 3 depending on how you go about it. And it is a little bit weird, I know that. Just give it your best shot. Yes, Evelyn, you are going to have to apply another rule at the start of this problem. Yep. Maybe about 20 more seconds. We're trying to do the second example. All right. Do I have a volunteer? Somebody that feels Pretty good about their answer? If not, I will call on a victim. Brianna, yeah, let's hear from you. You think you got it? You can either unmute yourself or put it in the chat, whatever is easiest for you. I think we're typing it in the chat. I can't tell. Okay, now I know I said you could type it in the chat or not, but can you turn on your mic? Because I think you're on the right track, but I think you made a mistake along the way. So can you kind of explain your process a little bit?
First, since the top number had like y to the second in parentheses and then a 2 outside of it, I multiplied both of those exponents to get 4. So you had y to the 4th, and then the bottom one is y to the 4th too. And so then I just subtracted that. Oh wait, it would just be y.
Yeah, so this is where we get kind of confused. I knew you were so close. You just made a little mistake. Thank you, Brianna. So here, now we have the same top and the same bottom. When we subtract 4 minus 4, we're just going to get 0. Huh, that's weird. But let's think about this. Let's go back to this middle step. I want to go back to where it says y over 4, y to the 4th over y to the 4th. In any other sense of math, whenever we have one number and divide it by itself, what would we get? So if I did 3 divided by 3, or 10 divided by 10, or -2 divided by -2, what would my answer always be? Yeah, 1. So this leads me to my next actually rule that says this is also equal to 1. So both of these answers are technically correct, but 1 is the even better answer, and I'll show you why. So let's move on. I'm actually going to skip to our 5th rule. So we're going to skip down to the 0 exponent rule, and this is what we just showed. And this is something that we're just going to have to memorize because it's one of those weird math rules. We looked and we said, okay, when we subtracted our 4s, we got 0, but also we know that this y to the 4th over y to the 4th, that's equivalent, that equals 1. So anything to the 0 power is always, always, always just going to be 1. You get rid of the base, the whole thing just becomes 1. It doesn't matter if it's x, y, z, q, p to the 0th. Whatever, that whole thing would just become 1. Okay? And if you were in class, this is where I would have you awkwardly repeat after me. Anything to the 0 power is 1. Anything to the 0 power is 1. Because it's one of those weird rules that we don't come across very often in life, but when we do, we need to know it. So I can 100% promise you that this will be on your quiz on Friday. So if you need to highlight that, star it, whatever we need to do. All right, then let's look at the examples here. So example number 1 for our 0 exponent rule. Now, we have 7x to the 0 power, and I know automatically you guys are thinking, well, this whole thing's just going to be 1. Okay, wrong. We are so close. But I want us to think about what coefficients actually mean. Before, when we just had like 7x, we know that 2 numbers right next to each other, they're being multiplied. So really, I could rewrite this as 7 times x. So if I have 7x to the 0 power, this is really the same as 7 times x to the 0 power. Okay? And now we know x to the 0 power, that's 1. So that x to the 0 power becomes 1, but the 7 is still there. So our final answer here would be 7. All right. Yeah, it's just 7. So I'm going to pause because that was a weird one. A scale of 1 to 5. Tell me where you're at. Yeah, the base goes away. If there's a 0 power, the x goes away, the y goes away, whatever. That whole thing just becomes 1. Good question. Good, seeing lots of high numbers. That makes me feel good. So the second one then, very similar to one we did before. We're going to have 2 rules here. We see this numerator can be simplified. Who knows what rule I would use to simplify the numerator? Go back to your notes. What rule would I use here? The power rule, you got it. So we're going to multiply those two. That's going to become w to the 8th over w to the 8th, which this is very similar to the one we just did above. When we subtract those, we get w to the 0 power, which we now know, looking at our 0 exponent rule, would just be 1. Awesome. So we have one final rule, and you guys have learned all of your exponent rules. Yay. All right. Looking at this top one, this negative exponent rule. So negative exponent, this one is the weirdest. I'm just going to be honest with you. And here's a little secret. Mathematicians hate negative exponents. They just hate them. They're cringy. We don't like them. I teach calculus, and we deal with a lot of negative exponents. But at the end of all of our problems, we always rewrite it so we don't have any negative exponents in our answer. They're just, they're a no-go in the math world. So if we see a negative exponent, we have to fix it. Otherwise, our mathematicians are going to freak out. So to fix it, we need to think about fractions. If I want any number to become a fraction, what do I have to do to it? Think back to Unit 2. If I want to make any number into a fraction, what can I do? Put a 1 under it. Yep. So boom. And then what our negative exponent rule says is it's kind of like, this is not an exact thing, but it's almost, it feels like we're making like a perpendicular slope a little bit. So to fix this negative exponent, you're going to switch which side of this fraction line it's on, and then you're going to change that exponent from negative to positive. So it now moves to the denominator, and it becomes positive. And then there's just a 1 up there. That was a weird one. So if you have any questions, feel free to throw them in the chat. All right, so let's look at this first example. In this first example, we're only going to fix things that are an issue. So kind of like this 7x to the 0 power, I want us to remember that coefficients they're being multiplied to all of our variables. So technically this negative 5x to the negative 2 is negative 5 times x to the negative 2. And now the negative 5 isn't a problem. We can have negative coefficients. We don't care about those. The problem here is that negative exponent. So that's the one that we have to fix. So I'm going to leave the negative 5 alone, but for that x with the negative 2, I'm going to move it to the denominator and change it from negative to positive. And I have my 1 up top. And then I can make this even prettier. If I just simplify that, it becomes negative 5 over x to the second. All right, questions? All right, then let's try number 2. This one is a bonus rule 1. I see a fraction looking thing. So Zane, what rule do you think I'm going to use first? We have to use 2 rules. This is a twofer. What rule do you think we're going to use first in that example? Zane, what do we think? Uh-oh. All right. What about Gabrielle? Gabrielle, what rule do you think we're going to use first in this example? Yeah, the quotient rule. We're dividing. So that means we have to subtract our exponents. And now our tendency always is to go, oh, 5 minus 2, that's 3. We have to do the top minus the bottom. So this actually becomes k to the negative third, because 2 minus 5 is negative 3. And then 4/8, 8 doesn't go into 4. We're not going to be able to make that nice and pretty. So we're just going to simplify that. 4/8 can be simplified to 1/2. And then this k to the negative third, we don't like that. That's a negative exponent. So I'm just going to flip it and put it to the bottom and make it positive. And now we have two fractions. And if we're multiplying fractions, all we have to do is multiply the tops and multiply the bottoms. You just multiply straight across. So we'd be left with 1 in the numerator and then 2k to the power of 3 in our denominator. Sorry, we're getting kind of small there. All right, and we are done. We have all of our exponent rules. Yay! So, pop quiz time. I'm going to give you guys a moment. Let's have all of you try those 5 problems. I'm going to give you about 2 minutes here to try those 5 problems. Oh, I will. Yes, thank you, Evelyn. I'll have you try those 5 problems, see how you do, and then I'm going to call on a bunch of people. So make sure you're ready. You can, if you're taking notes and you printed out the handout, you can just flip it to the blank, to the back side, it's blank. Or if you're just on a separate sheet of paper, obviously you can write that anywhere. So again, we're trying these 5 problems. I'm giving you guys a minute. I want you, even if you're a little bit unsure, I want you to write down an answer. Try it out. The worst thing that happens is you make a mistake now, but it's better to make a mistake now than on the quiz on Friday, because we can correct it now. Give about 20 more seconds here. All right, I'm going to have Damari, you're going to give me my answer for number 1. Caitlin, you are going to give me my answer for number 2. Bailey, you are going to give me my answer for number 3. Saraya, you're going to give me my answer for number 4. And let's have Evelyn give me your answer for number 5. You can either type it in the chat or unmute yourself. Oh, Mrs. Lehman, you probably need me to unpause the activity. Is that why? All right, you guys, everybody was supposed to give me answers. All right, awesome. Damari, we got x to the 18th. Good job. Caitlin, yep, you were using the product rule. It's x to the 10th. Good job. Evelyn, 1 over m to the 5th. Awesome job. Soraya, oh, number 4, remember that's our quotient rule. So we have to subtract those two exponents. So if we subtract those two exponents, what would we get, Soraya? And then Bailey, I'm still waiting on you. There you go. C to the 8th, good job. Bailey? I don't know what happened to my video. Can you guys see me? What's happening? All right, anybody, let's hear number 3. What's our answer to number 3? Yes, thank you, 1. Yeah, I don't know why I just, hi, here's my hand. You can sort of see my hand. All right, I'm going to stop recording here.